Okay, let's look at our first example then. So graph y equals 2x minus 6 over x plus 2 without the use of technology. Find the following to help you with your sketch. So my horizontal asymptote, well, that's going to occur at my leading coefficient divided by my leading coefficient. So 2 divided by 1 is 2, and that's going to be at y equals 2 then. So therefore, y equals 2. Our vertical asymptote is going to happen at our NPV. Well, that's at negative 2. So it's at x equals negative 2. Our y-intercept, okay, so we can spend a second doing that. So we're going to let x equal 0. So we go y equals 2 times 0 minus 6 all over 0 plus 2. So you get negative 6 over 2, which is equal to negative 3. So that means our y-intercept is at 0 comma negative 3. Next, our x-intercept. And I'm going to let y equal 0 this time. Now it's going to be really quick to simplify because I'm going to multiply both sides by x plus 2, which just leaves me with 0 equals 2x minus 6. Add 6 to both sides. Divide both sides by 2. And you get x is 3. So therefore, I have my point at 3 comma 0. And then it says we could plot a couple more points. We're not really too sure, though, where those points should be at this point. We could do this with well, you could maybe do this with transformations. We don't want to, though. We want to do this here. So we're going to just right on the right side and start plotting what we know. So we got a horizontal asymptote at 2. That's at y equals 2. And then a vertical asymptote at negative 2. That's x equals negative 2. Okay, our y-intercept is at negative 3. So somewhere down here-ish. Again, it's a sketch. We're just trying to put the major points. X-intercept is at 3. And so we got to imagine we got something kind of curving from here to here. It might be nice to have a point in here to kind of show what that curve would look like. We know it's going to approach this asymptote, and we know it's going to approach our vertical asymptote on this side. So there's a point that might be nice to have. Based on this graph, or what's sitting here, I'm thinking that maybe 2 might be better than 1. Maybe it doesn't really matter too much, but I'll do 2. So we're going to let x equal 2. And so y, 2 times 2 minus 6. And so you get, what, 4, negative 2 over 6. Maybe that wasn't the best point. And so you get negative 1/3, which that's all right. So then we get at least a little bit more guide. So we know x, where x is 2, so it's here-ish. And we'll say that's at negative 1/3. Okay, so I'm going to sketch that part of the graph now. I've got a pretty good idea what it's going to look like. Now for my other side, we don't really have any other information about my graph up here. If we have one here, we should have something happening here as well. So I need to find some points on that side, and they're going to have to be where x is smaller than negative 2. So let's pick something like x is negative 6. Let's do negative 6. So let x equal negative 6. And we're left with negative 6 plus 2. So what do you get? You get negative 12, negative 18, all divided by 4. It doesn't quite work out that nice, but you do get negative 4.5. So at least it's reasonable, somewhere we could put it on there. So if I go and graph this then, put that point, negative 6 comma negative 4.5. So if that's negative 2, negative 6 is going to be way over here. And it should be negative, negative, positive. There we go. That fixes that. Should be a positive 4.5. So negative 6 and then 4. If that's 2, let's say up here somewhere. So negative 6, comma, 4.5. That's a positive. All right, let's do another one, even maybe smaller. We know that it's going to approach this way as well. Let's just do one more. Let's do negative 8. So let x equal negative 8. And we're going to have y equals 2 times negative 8 minus 6. And then negative 8 plus 2. So here you get negative 16, negative 22 over negative 6, which is approximately like 3.6 repeating. So if we're going all the way to negative 8, so let's just say it's about there. We're getting smaller, but not smaller so super fast. So negative 8, 3.6, and yes, that is a mathematical term, so super fast. So there we go. There's kind of a sketch. We've got our asymptotes, which are really important, and we've got our x and y intercepts. All right, one more question. So graph y equals x squared minus 5x plus 6 all over x minus 2 without the use of technology. Find the following to help you with your sketch. Now, probably right away you're thinking, so now I got to go and do those oblique asymptotes, which is good if that's what you're thinking, because our numerator degree is greater than our denominator. But we should always check, can we factor this and cancel something out? So let's look at that. We get y equals, and then it's going to become x minus 2 and x minus 3. Oh, well, yeah, I can cancel that x minus 2 out. So this is actually just a linear line of x minus 3. So I don't have a vertical asymptote. So there's none of those. There's none of those. I probably do have an x and y intercept, so we can figure those out. So let y equal 0. So then we find out that we add 3 to both sides, and hey, our x-intercept is at 3. So that means we got 3 comma 0. So now if I'm sketching this out, so I have 3 comma 0 already. Let's do that in red. So 3 comma 0. And this is my x, that's my y. And our y-intercept, well, we can find that out just from here because of the form it's in. So we know that that's going to be a negative 3. So 0 comma negative 3. Now, it might seem as easy, hey, I just got to connect these lines now. You're missing one crucial step, though. We did some canceling here. So we have an MPV of x cannot equal 2. So that means at 2, we're going to put a little open dot, or there's a hole in the graph. Now we should actually label what that whole thing would be. So we're going to go inside this equation, and we're going to let x equal 2. So y equals 2 minus 3. So therefore, our point of discontinuity is when x is 2, and that's going to be a height of 1. So we go and find that, or negative 1. So somewhere like here, and we'll label that 2 comma negative 1. There we go. We're done.